Hi, hello everyone. This is Dr. Chiranjeevi Manike, Professor and Head of Data Science and Cyber Security Department, MLR Institute of Technology, Hyderabad. As part of data mining video lecture series, in this lecture we are going to discuss decision tree introduction. So let us start with what is a decision tree. Then we'll see some history who introduced this decision tree, what are the different versions of this decision tree, and we will also see the algorithms. What are the steps, step-by-step procedure we need to follow to construct this decision trees. So decision tree induction is the learning of decision trees from the class labeled training tuples. So it is a flow chart like a tree structure, but it is only for understanding, right? Actually, this tree, the decision trees would be represented in the form of rules. So where each internal node or a non-leaf node denotes a test on an attribute. So we from the bottom, so we have to split the attributes based on, so each step we use the attribute to test, and we'll split the attributes accordingly. So each branch represents an outcome of the test, and each leaf node or the terminal node holds a class label. So the topmost node in a tree would be the root node. And this is one simple example to understand how the decision tree flow chart would look like. So here we have like the age attribute, and this is the first attribute that is we use to test. So based on that, and the age attribute has three values, three different categories like a youth, middle aged, senior, etc. Again, and here we would select the student as a attribute that is to test, and similarly the credit rating would be used in this branch to test like this. So there are the leaf nodes. Those are the target, the class labels. So some decision tree algorithms produce the binary trees. That means each attribute would be having a two values. That means where each internal node branches to exactly the two other nodes, whereas others can produce the non-binary trees. So from a given a tuple for which the associated class label is unknown, the attribute values of the tuples are tested against the decision trees. A path is traced from the root to a leaf node which holds the class prediction for that tuple. Like in the previous example, just quickly go back. Like suppose age, if age is youth, then student is student, yes. If not, no. Like, so we'll trace the path that is to find out the decision, right? Whether yes or no. The yes or no are the target labels. So a path is traced from the root to the leaf node, which holds the class prediction for that tuple. So decision trees can be easily converted to the classification rules. Like suppose in this case, this here we convert this decision tree into a classification rule, like if age equal to youth, and the student, okay, the question mark, yes or no. So then it leads the, if student is yes, if age is youth, student is yes, student yes, then the outcome would be yes. So like this, this is one rule. And similarly we could also do another rule, like if age equal to youth and the student no, okay, here there is another possible value for the student, like, and then, so this is the way we can, but we will discuss in the coming lecture in detail once we construct the decision trees. So decision trees can be easily converted to the classification rules. So the construction of decision tree classifier does not require any domain knowledge. That is why the decision tree classification or the decision tree classifiers are so popular. It only requires, that is a basic knowledge. The decision trees can handle the multi-dimensional data. So their representation of acquired knowledge in the tree form is intuitive and generally easy to assimilate by the humans. So the learning and classification steps of decision tree inductions are simple and fast. In general, decision trees classifiers have the good accuracies. However, successful use may depend on the data at hand. Decision tree induction algorithms have been used for classification in many application areas such as manufacturing, medicine, production, financial analysis, astronomy, and molecular biology, etc. The decision trees are the basis of several commercial rule induction systems. Let us quickly go through the history. During the late 1970s and the early 1980s, the Rose Quinlan, a researcher in the machine learning, developed a decision tree algorithm that is known as a ID3, that is iterative dictomizer. So this work expanded on earlier work on concept learning systems that is described by the E.B. Hunt, Marin, and Etier. The Quinlan later presented the C4.5, that is a successor of ID3, and which became a benchmark to which the newer supervised machine learning algorithms are often compared. In 1984, a group of statisticians published the book called as the Classification and Regression Trees, CART short name, which described the generation of binary trees, that is ID3 and CART. So those were invented independently of one another at around the same time. And it follows the similar approach for learning the decision trees from training tuples. The two cornerstone algorithms spanned a flurry of work on this decision tree induction. ID3 and C4.5 and the CART adapt a greedy, that is non-backtracking approach in which the decision trees are constructed in a top-down, recursive, divide and conquer manner. Most algorithms for decision tree inductions also follow a top-down approach, which starts with a training set of tuples and their associated class labels, etc. The training set is recursively partitioned into the smaller subsets as the tree is being built. So let us quickly see what are the steps like in this decision tree construction algorithm. So the first step, like that is the first one is we could divide into three major categories. The first one is input, that is the data partition D, which is a set of training tuples and their associated class labels, and it has attribute list, that is set of candidate attributes. And second one is another important one is a measure, that is the attribute selection method. So that, as we discussed like just now, the every node we have to select the attribute, that is to perform the test. So the attribute selection method is going to play a major role here. It is a procedure to determine the splitting criteria, how we are going to split the attributes, so that best partitions the data tuples into the individual classes. So this criteria consists of a splitting attribute and possibly either a splitting point or the splitting subset. That means either split point or the splitting subset. This would be generated by the attribute selection method. And then the output is the decision tree. Let us just, before we proceed to have a in detail discussion of each step in this decision tree algorithm, let us try to understand what is the data, the input. As we discussed, mainly there are three, right? Input is another first thing, and second one is attribute selection method. So now input, what kind of input, how the input would look like. So this is a data set with these are all the points, observations or points, okay, samples, and these are the features like day, outlook, temperature, humidity, wind, and then it has the class label, that is a play tennis, yes or no. There are only the two outcomes, either yes or no, or we could say there are two classes, no and yes. Now let us just quickly understand what is each step, right? What we are going to do. This is a detailed pseudocode of this decision tree construction algorithm. So first we have to create a node, and the second, if the tuples in the D are all of the same class. Like the previous in this data set input, and the tuples in this data set are belongs to the two classes. One that is yes, another one is no. There are only the two classes in this data set. So if the tuples in the D are all of the same class, let us say the class is C, then return n as a leaf node that is labeled with the class C. Next, if attribute list is empty, then return n as a leaf node labeled with the majority class in the D. That is based on the majority voting. Next, apply attribute selection method. This is another thing. If there are attributes, then we have to select it. So which attribute need to be selected to split the data set into the partitions. So this here, it is going to take the parameters like a D and a attribute list, because if this condition is true, and this will be this part. If not, that means that it has some attributes. So then that need to be supplied to find the best splitting criteria. Next, label the node n with the splitting criteria. So if a splitting attribute is a discrete valued, again the splitting again based on the three conditions, mainly there could be three possibilities. Like the splitting attribute, the values are the discrete values, or it could be the continuous values, or it could be the discrete and the binary values. So for each category we have to act accordingly. So multi-way splits allowed. Then next, for each outcome j of a splitting criteria, partition the tuples. So like suppose there are three categories or three outcomes, or if the data set, the tuples are divided into the three partitions, so accordingly we have to partition the tuples and grow the subtrees for each partition. Let dj be the set of data tuples in the D satisfying the outcome j. Here let us say, like suppose yes is a one outcome, that is from the example data set that we have seen in the previous slide, and no is another outcome. So let us say this is represents the j outcome. So let dj, that means the set of all tuples, whose outcome is yes, right? And suppose I equal to 1, let us say j equal to 1, or d, and let us say d1, and this is d2. This is one partition, that means the set of all tuples where the outcome is yes, and these are all the set of all other tuples where the outcome is no. So if dj is empty, that means any particular set of attributes in this data set is empty. So attach a leaf labeled with the majority clause D to the node n. Else attach the node returned by the generate decision tree. So then this repetition, recursively we have to again go further, and then again select the attribute and test the attribute, and then divide the data set, that is the set of all the tuples, into the partitions, etc. So once it is over, then it would return the decision tree. So let us quickly see. There are, as I said, there are three possible values. Like a splitting attribute is a discrete valued or continuous valued, or discrete and binary. So for example, in this case, like here, partitioning scenarios, and you can also see the examples also. This is like suppose the first case A, that shows if a discrete attribute A is an attribute in this data set D, and it has the possible values. There are V like A1, A2, and so on, AV. There are V unique values A under this attribute. There are unique values. Let us just quickly go back, and here you can see if you take the attribute as an outlook, and what are the unique values under this attribute. Like sunny is one unique value, overcast is another unique value, rain, and yeah, so these are only the three unique values. In that case, V is equal to 3. So then we have to partition accordingly, like for each category. So there will be a partition, or if the categorical data like the color, like red, green, blue, purple, like this kind of a partitioning would be done. If the income is a attribute value, if it may have the like the categories like low, medium, and high. In that case, then the data set that would be partitioned into this different categories. Next possibility is if the partitioning attribute, the possible values are continuous values. So then the partitioning attribute. So we have to select the partitioning attribute. So that partitioning attribute selection would return a point called as a split point. So based on that split point, then this would be divided into the partitions. Like suppose one partition would be having the values which are, that is, less than or equal to the split point. Another partition would be having the values greater than the split point. For example, income, the continuous value, if it has a continuous values, then less than 42,000 would be divided into the one partition, and greater than 42,000 would be divided into the another partition. Next, third case, that is where the attribute, partitioning attribute, the possible values are like discrete or binary, like suppose yes, no, 0, 1, like that. So in that case, we partition the data, the tuples into the accordingly. So for example, here color, that is red and green only, whether the red or green. So then yes and no are the outcomes. Accordingly, the partitioning, the splitting would be done. So thank you for watching this video. So now next lecture we will discuss, we are going to apply this, whatever we discussed in this, the steps, what are the steps we discussed in this decision tree construction algorithm. So we are going to apply this, and mainly the before that, before we construct, we have to discuss, or we need to spend more time on understanding how the attribute selection would be done, because we cannot simply randomly select an attribute. So there are some measures we need to use so that whether the selection, the testing attribute is accurate or not. So that we are going to discuss in the next lecture. Thank you for watching this video.